talk about radians. We're going to discover what they are. So, here are the steps we're going to follow. Choose a circle from the previous slide. Mark the center of the circle and label it 0. So yes, I actually want everybody to do this at home. So get a piece of string and choose a circle. Then you're going to place a point anywhere in your circle, and then you're going to move that around your circle and put a point everywhere you hit. So I'm going to model it for you roughly with that's a big old radii. Okay, so there's my radius. You will cut your string like that. Now I'm going to put a mark right there. Okay, now there's going to be a little bit not perfect because this is going to move on me, but I'm going to try to keep it the same length. So there's my another mark. About there. And then I'm going to swing around that way. I see it's moving on you, but your string won't move. So that'll be another mark about there. Okay? And you're going to swing it around like so. And you're going to keep doing that until you get back to start. Okay? So just do that once, pick any of the circles. Hopefully people pick different circles, and we'll talk about this in class. See what happens. So, you're going to estimate, before you start moving it, okay, how many of those radii fit around the circle. Okay? Now, number 2 you can't do unless you want to text a friend who's in your class and do it there. But we'll get some other values from students in class to see what they guessed. Okay? So we'll talk about number 3 and 4 in class before we start the left practice for the day. But you'll hopefully see when we talk that most people got somewhere between 6.1 and 6.4. This happens because the imprecise method of measuring and estimating. What value should everyone get and why? Hint, we're trying to determine how many radii fit on the circumference of a circle. So we'll find out what the actual answer is. Okay, so we'll figure out the exact number, but based on somewhere between 6.1 and 6.4 that you guessed, that you had to pick a decimal place, how many radii will fit exactly on half the circle, half the circumference? Well, 6.2 divided by 2, about 3.1. And a quarter, 6.2 divided by 4 equals, 4 goes into 6 once, 2 left over. That's going to be 22, so 0.7. I lied, 0.55. Wasn't thinking. Approximately. Okay? So let's see what a actual radian is. A radian is the central angle that intercepts an arc length of 1 radius. Okay, so here's a radius right here, right? Let's say it's 5 inches. Well, this central angle with the same radius, this measurement of this arc length is also 5, for example. So notice we have R, R, and R. So these are all 5. But to get this specific arc length here, we have to have a specific angle right here. And we call that 1 radian. Now, we know that a circle has 360 degrees. Well, it has 2 pi radians. So if you think about it, just with a quick estimate of 3.14 times 2, that equals 6.28. And remember we talked about how most people got between 6.1 and 6.4 for an estimate? Well, there you go. So before we talk about a semicircle, 180 degrees is going to be equal to pi radians. So 3.14, so on radians. So here's how we're going to convert it. It's actually pretty easy. The understanding might be a bit hard, but conversion is pretty easy. 1 radian is equal to 360 divided by 2 pi, and 1 degree is equal to 2 pi over 360. So let's see how easy this is. It really is. When we convert a degree to a radian, we multiply by pi over 180. Okay? So, 30 degrees, that's over 1, times pi over 180. Okay? Well, 30 goes into 180 6 times. So that's pi over 6 radians. Clean it up so we're not crossing out words. Okay, so 270 over 1 times pi over 180. Okay, well, what goes into 270 and 180? 90. How many times? 3 times? 2 times. So that's 3/2 pi radians. It'll get better after we practice some more. Now, we're going the other way. We're converting radians to degrees. We multiply by 180 over pi. Just flip it. So 3 pi over 5 times 180 over pi. Well, first off, the pi's are going to cancel. Now we can do 3 times 180 on our calculator divided by 5. Or we can do 5 goes into 180 and times 3. We can reduce, whatever we want to do. If you have a calculator, you can simply type in 3 times 180 divided by 5, which is 108 degrees. Now remember, if you wanted to, you could have done 180 divided by 5 first, cancel, and got 36, and 3 times 36 is 108. Now try with this one. Pi over 12 times 180 over pi. Again, the pi's cancel, and then you simply do 180 divided by 12, which is 15 degrees. So the conversion is pretty simple, not too complicated. I know the concept of a radian is new and kind of different, but we'll work through it. That's it.